Alright, hi everyone. This video I'm putting together to hopefully explain to you guys some of the more useful aspects of object-oriented programming, or OOP as it's often abbreviated. Having taken some computer science classes, I'm assuming you're all familiar with object-oriented programming, but hopefully here we can expose some attributes of it that are maybe you weren't exposed to in your earlier classwork. So, and hopefully this can be a little more directly applicable to your airfoil project that you're working on. So, let's dive in. I've just got a blank script here. I'm going to start out by importing JSON because I'm going to need that for reading input files. And then I'll put in my if name equals main construct because I want to be able to test this out, but I also want to be able to import my classes later. So the idea of object-oriented programming, the idea of classes, is that you create these data objects called classes. And not only can those data objects store information, like variables and whatnot, but they can also have functions tied to them. We call those member functions in Python. So say I've got a class, and I'll call that airfoil. And there's some things that I want to be able to do with the airfoil. First, I want to be able to calculate its geometry, like we've talked about in class. Well, I can define a function, def geometry, and that's a function of the x location, and I want it to be able to return camber, upper surface, lower surface. Okay? And there's going to be some kind of calculations in here to figure out camber, where say camber is equal to 0.0 initially, upper surface is going to be equal to, and you know, for now, let's deal with a cylinder, even though you guys will be dealing with an airfoil event, or will be dealing with an airfoil eventually. The upper surface will be, let me import NumPy so I can use that. So my upper surface will be np.square root of r, the radius, squared minus x squared. Okay, and I can, it's almost the same calculation for the lower surface. And for those of you who are having trouble following exactly what my cursor is doing, I'm using a text editor extension called Vim. It's really useful. I recommend it if you have the time to learn how to pick it up. It's a little tricky, but it's really useful once you get used to it. Anyway, so this defines our geometry for our airfoil, or for our cylinder here. Problem is, I've said we need to use this r value here for our radius, but we don't know what that is. Well, what we can do is we can say that that is a member variable of this airfoil class. We'll call this self.r. Oh, and I forgot. Sorry. Proper syntax for defining a member function of a class in Python is that the first argument is always a variable called self. And that first argument is the object that you're calling this function on. So if I come down here and I call, let's say I initialize some airfoil, my airfoil is equal to airfoil. So I've instantiated an airfoil object, and now I'm going to call the geometry function. So camber upper lower is equal to my airfoil dot geometry. Okay, and I want that at 0.5. What's happening here is that even though geometry accepts two arguments, since it's being called as a member function, this my airfoil is being passed in as the first argument to geometry. So that's what this self is doing. That's referencing the object that we're calling this on. Okay. Well, problem is we've not set what r actually is. Now, really, we don't want r to be changing throughout our computations. So I'm going to create an initialization function. Again, the first argument needs to be self, and then I'm going to pass in the radius value, and I'm going to say that self.r is equal to r, whatever I pass in. Now this init function, which is surrounded by double underscores, is what gets called anytime you have you instantiate your object. So anytime I call airfoil and I've got the open and close parentheses, it's calling this function here. So I need to put in my radius. I'll say my radius is 2, okay? And then I'll just go ahead and print what my camber and my upper and lower surface are. Okay, let's go to the terminal. Lovely. So it's giving me, that's the Y location of my camber, that's the Y location of the upper surface, and the Y location of the lower surface. Looks pretty good. So, recap really quick. We've defined a class called airfoil. In the initialization function, what we're asking for is a radius. And then we've got a geometry function that uses that previously stored radius and calculates all the geometry for us. When we instantiate it, we give it the radius that we want to use for this particular airfoil. And then we call myAirfoil.geometry, and we proceed with our calculations. The nice thing about this is that now I can go ahead and I can create a second airfoil, my second airfoil, and I could instantiate that with a radius of, say, 1. And now you can see this is my geometry as defined for the cylinder with radius 2. This is my geometry for the cylinder with radius 1. This is why object-oriented programming is really, really nice. All of this code, I only ever have to write once. It's all copied over, and I can just instantiate different objects that have different properties. Okay. Now we could also do, we could pass in, say, I want to be able to change the center location of this airfoil. So self.x center, and then in here I'll have to change this to be, gee, what would that be? X minus X cent, and same thing here. So now if I want to shift this airfoil so that it's at, the center's at 0.5, I'd pass in that second argument like that. Oh. I need to use self there. Ah. It would help if I stored that. There you go. And now you can see, even though I'm calling it at the same X location as before, I'm getting different Y values because I've shifted the center of my airfoil or of my cylinder. And you know what? To make things less confusing, we'll just go and I'll go ahead and call this cylinder. Okay. Now for what you guys are doing with the airfoil project, you're also going to have functions. You're going to have a streamline function where you're going to give it a start and you're going to give it a DS, and it'll do some calcs, and then it'll return a streamline array. Or for now, I'll just call streamline is equal to some list. Okay, and I could, if I wanted to come down here and outside of my airfoil class, I create a plot function or a plot streamlines. Then what I'm going to pass into that is my object. So we'll call it flow object. And then, you know, certain parameters as to how many streamlines, n streamlines. The really cool thing about these objects is that if I have another object, say called airfoil, and for my airfoil I define a streamline function and I define a geometry function, then in here I can just tell it, you know, to get the streamline is equal to flow object dot streamline, and there'll be some start and some DS initialized there. As long as this flow object that I pass in has this streamline function defined, then this code here doesn't actually care what this object is. As long as those functions are defined, it doesn't care. And so if I've got another if I've got another function, or if I've got another class, and we'll call this class airfoil. And obviously these calculations are now going to be different, but I'll just leave them as they are for now. This plot streamlines function is dependent upon geometry, it's dependent upon streamline, but since these two objects have the same member functions, this is ignorant as to exactly what type of object that is. It'll take it in, it'll call the functions that it needs, and it'll do its thing. So if you'd like, and this is what I would recommend, it's really helpful to structure your code this way and store things in objects and have common function names between these objects. You know, you could have an object that defines a cylinder, an object that defines an airfoil. Later on you may have an object that defines a Zhukovsky airfoil. Anything like that, as long as they've got these same member functions defined, like streamline and geometry, then these outer functions that you wrap around these objects can work no matter what the objects actually are, which makes your life a whole lot easier. So I recommend trying to work on it that way. I think that's all I want to explain for now. Hopefully this is helpful. Based on your feedback from this, I may create a more in-depth tutorial as a follow-on to this, but we'll see.